Hey, welcome back. This is Shoptalk number something for November 2017. I just wanted to give you a quick update, what I'm up to in the shop, and a few little things here and there. So let's go. So one topic that comes up quite often is I get asked, why do you have so much Morse Taper 2 tooling and why do you use it instead of a larger taper? The simple answer is I use it because I have it. I had a lot of Morse Taper 2 tooling from my last milling machine, and also the tailstock of my lathe is Morse Taper 2. But my new milling machine has a Morse Taper 4 in the spindle, which is one of these tools here. This is a Morse Taper 4. As you can see, this is quite a massive taper. It's about as rigid and as solid as a number 30 steep angle taper, which you will find in something like a robo drill or a small VMC of any other make. So this is a relatively large and robust taper compared to the Morse Taper 2, which looks a bit dinky. But I mostly use relatively small tooling. This is a 10mm end mill. This is about the largest end mill I use on a regular basis. And that's something that I can do with Morse Taper 2 without a problem. The Morse Taper 2 is cheap. It's relatively short, so I do not have to crank the head of the mill up so far to get my tools out. It's about twice the length, almost twice the length, that you need to retract the head of the mill to get a Morse Taper 4 out instead of a Morse Taper 2. They are light, fast and easy to handle. I can machine them on my equipment. The Morse Taper 4 is on the edge of what I can machine on my lathe without having to set over the tailstock. The Morse Taper 2 I can cut with the compound. And I have a lot of tooling for it. That's the other reason. I have my good Albrecht chuck sits on a Morse Taper 2 shank. I have a number of small collet chucks. ER16, I have 3 or 4 ER11 chucks that I can just set up with a tool and change out very fast. I have some Weldon end mill holders, and of course I have the Morse Taper 2 collets, which I use very much. I made a number of arbors for slitting saws, shell mills, gear cutters, form cutters, all that stuff, all shop made. And also a fly cutter. This is a carbide fly cutter. Just yeah, it doesn't get more basic than this for a fly cutter. And of course the beautiful Woolhopter UPA1 boring head. This is also Morse Taper 1, Morse Taper 2. So yeah, that's my reasoning behind the Morse Taper 2 tooling. It's stiff enough for the work I do. It's light. I can make them myself in the shop. Morse Taper 4, I could do it, but would be way more effort and way more material to use. The overseas stuff in Morse Taper 2 is very cheap. Even the good quality stuff from Bison, which is a Polish company making tooling, is very affordable. The thing about Morse Taper is if you overcrank the drawbar, you have a hard time to get them out of the spindle. So do not overcrank them. With solid shank tooling like an arbor or a collet chuck, you do not really need to tighten the drawbar very much. Just a little bit. It's another thing with the collets. These need a little bit more torque, otherwise you will get into the danger of sucking the tool out of the collet if you're doing heavy roughing. But that's another topic. Yeah, that's Morse Taper 2 tooling. I like it. It's compact, it's light, it's fast to change. And yes, I have really a lot of Morse Taper 2 tooling. All the stuff here on the right side is Morse Taper 2. All the arbors and centers and stuff like that, all Morse Taper 2. And of course my tool carousel on the mill, all Morse Taper 2 up here, and down here all the Morse Taper 2 collets. So yeah. While we're at the matter of tooling, let's talk about the Annular Cutters that I showed in the last video. The question that comes up quite often is what I do for holding them in the machines. And the answer is I made a holder. This is a Morse Taper 2, again Morse Taper 2 holder. I took a blank Morse Taper 2 arbor with a soft end, which is not really soft, they are still quite tough. And yeah, they're tough. It's better to use carbide to machine them. And it's one of the blanks with a drawbar thread on the end. So I can use them in the mill. This is a screw-in tang, so I can use it in the lathe and get it out again. It's bored to 19.05, which is, I guess, 3/4 of an inch. Relatively close fit on the shank, on the cylindrical shank of an annular cutter. Surprisingly, this diameter on the annular cutters has quite a bit of tolerance. I measured a few of them and they range from 19 to 19.1 millimeters. So yeah, it's not a super high precision diameter. They have two flats machined onto them, ground, 90 degrees apart, and that's what holds them in the holder. Two set screws with a flat head, flat tip that is. Flat on the end, and they press against those two flats. Do not use cheese grade set screws. Use really high quality ones, tempered, otherwise you will strip out the threads in no time. If you're in the part of the world that's using imperial, you can use a 3/4 inch collet, I guess, like a R8 collet, 3/4 of an inch, and clamp directly on the shaft of the cutter. But in Europe, that's of course not common. I wouldn't hold it in an ER style collet because the shank is very short and the ER collets need a minimum length of engagement in the collet. You need to fill at least 2/3 of an ER collet, and ER 32nd, 32, which is the which would be the smallest size that you could use to hold a 90mm shank, is a relatively large collet, and you would not be able to get enough gripping length here. So you can use either a pull type collet like R8 or Morse Taper 3 up, or 5C if you have a weird milling machine with 5C on the spindle. Don't know if that exists. Or you can use a weld-on type holder, which I would prefer, because if this spins in your collet, the collet does not, it wouldn't do any good to it. I would recommend this style of holder. You can buy them. You can even get them with through coolant. Then they have a ring, a friction ring with a barb fitting to get a hose with coolant in, and you get coolant through the cutter, which would be quite nice. But they're relatively expensive. I think they are about 160 euros. And they come with a Morse Taper shank. I think 2 and 3. The Morse Taper 2, I wouldn't go above, I think this is the largest cutter I would use with a Morse Taper 2, because this has its limits. You don't want to shear it off or spin it in the collet, which would be spin it in the spindle of your mill. This would be quite tragic. And I got a new surface plate right here. Before this I had a Chinese 400 by 300 grade 00, which did me good service for a lot of years. I bought this short after I started out doing machining work in my own shop. Back when I had a small mini lathe 7 by 12, and I wanted a surface plate, so I bought one of the Chinese ones. It worked very well. It was reasonably cheap. I think I paid less than 150 euros for it back then, and I got a lot of use out of it. And it was relatively accurate. If it wasn't, I would have seen if you do scraping and you blew up your part in one corner of the surface plate, then in another corner of the surface plate, and the pattern you get changes, you know that something's wrong with your surface plate, and that didn't happen with that plate. So I guess it was reasonably flat. But I do more and more work, outside work for other people, and I was thinking that I should get a known good surface plate with a proper test report. So I was looking into different manufacturers. There are, I think, 3 large German companies that make surface plates. Planolite is one of them, Tome is one of them, and there is a third one I cannot remember. And there is my tooling supplier, Hoffman Group, which has their house brand Garant, and they rebrand German-made tooling like surface plates, wrenches, pliers, all kinds of tooling, and sell them under their own brand name for a little bit less money. And they do that with surface plates too. So I got a Garant surface plate, which is a German-made surface plate. 630 by 400 millimeters, grade 0. Grade 0 is allows on a surface plate of this size to be up to 7 thousandths of a millimeter out of spec, or out of flat, not out of spec. 7 thousandths of a millimeter out of flat. That's 3/10 over the whole surface. 3/10 thousandths of an inch, roughly. But they're very conservative what the use of tolerance is. In reality, they use about half the tolerance allowed, just to be sure. And I have the test report for the surface plate, and I will show that to you. Okay, let's go over it. We have a surface plate, 630 by 400, 70 millimeter thick. Drawing number, that's internally for the company that made it. The datum of when it was checked, 17th 7/2017, Mr. Fleischer with his own signature. That's a real signature, now they copied one. The tools they used to check it, Blue Meter Sigma S1925, which is just a display unit for the blue level 2830 and 2831. These are precision levels, and this is just the display unit. So they mapped out the surface plate with high precision levels, and the blue meters are from the Swiss company Wyler, which is the company to go to if you need a precision level. I will link down in the description a really awesome promotional video of theirs. They even show some hand scraping in the video, so it's quite cool. Then the standard DIN, which is Deutsches Institut für Normung, German Institute for Standards, 876 and /0. That's the grade. It's a 0 grade plate. Allowed tolerance, 7 thousandths of a millimeter, 7 microns. that means that every point on this plate is between two planes that are 7,000 of a millimeter apart, or could be between two planes that are 7,000 of a millimeter apart. And that's the actual measurement. That's the largest deviation from highest to lowest point on this plate. 3.46 thousandths of a millimeter, which is pretty much half the allowed tolerance. That's pretty darn good. I would say for general shop use, if you're not doing super mega high precision, aerospace grade, whatever stuff, that will work out. And you get a topographical map of the surface plate. With the left bottom corner as the 0, and then you get this a topographical map where the high and lows on this plate are, with actual measurements. So that's quite nice to have that. As you can see, this plate is slightly low in the middle and it's a bit high here, almost out to the corner. I personally would prefer if it was high in the middle, because that's the area that you use the most and wear down first, but you can't choose. So if I ever wear down this plate, I will just relap it, or have somebody come in and relap it. That's not super expensive, and Hoffman Group will have somebody relap it for you for a reasonable price. And you get an actual inspection sticker with a proper surface plate. Next date of checking is middle 2019, so it's a 2-year recurring check if you want to be ISO 9001 conform, which I'm not. But it's it's a nice touch to have this in the shop, have a proper known good reference surface. As you can see, it sits on 3 points here, here and over here, which are the 3 points that the surface plate was resting on while it was ground and lapped. So by setting the plate on the same 3 points every time, they can assure the precision of the plate. That way, it's everywhere you place it the same. Right now it's just sitting on top of the steel cabinet here, but I plan to make a frame that goes on top of the cabinet and has 3 proper mounting position, kinematic mount for the surface plate. One V, one conical point and one free floating. So if the plate has some thermal expansion, it can freely move and not distort the plate. Which right now I can move freely too, but it's just sitting there. And that's a bit how you do it. I have some footage of stainless steel bushings I had to make for a guitar maker. 60 of them, so I had to figure out a good way to make them without hundreds of setups in a row and taking forever. So I have some footage where I show the process. I'm using 10mm stock and I clamp it in a collet. And to get the right stick out, I pull the material out of the chuck and I use the tailstock with the drill in it as a depth stop to adjust my stick out. Then I use a purpose ground parting tool to face the part. Do the OD turning. This is free cutting stainless 14305, which machines very beautifully. Taking a finishing cut, tolerances are not too fuzzy. I machined them to plus minus 200ths of a millimeter on the OD, on the smaller diameter. Taking a facing cut out, going back in, machining the larger diameter Still with the same tool. Using a fine cut file to deburr the edges. Using a 2.5mm stub drill to punch in a hole all the way through. Using a small countersink to deburr the hole. And using the parting blade to finally part off the the finished part. That allowed me to do the whole job, the first setup, without any tool changes, which made it go quite fast. Compressed air to clean it, and 59 times more. Went quite fast that way. It's not too bad. So this is the tool I used to do all the turning, parting and facing. It's a Horn 312 series parting insert that I changed to do turning as well, so it can turn, face and part off with a reasonable good finish. And yeah, it's 1.5mm wide, so it doesn't put too much load on the work or on the machine while parting. And yeah, I buy these used and I regrind them to every possible shape I need. A new insert from Horn costs about, I think, 15 to 20 euros, and you get 3 cutting edges with them. You are limited with the diameter you can part off with them, but that's a minor drawback because for very small work these are really, really nice. Well worth the money, even if you buy them new. Just don't break them. Most of the time when they break all the way through the center hole, and the remaining cutting edges get useless. This is the parting tool that I changed on the grinder to do turning to the side, parting and facing. As you can see, I ground quite a bit of clearance on the side of the insert here, so I can do normal turning. I ground the top of the insert too with a little bit of back rake, so because this insert was worn out. And as you can see here, it has a side rake to the right end, so it can do turning too. And a little bit of back rake here, side clearance here too, so it can do facing, and it still can do parting. So this is my universal tool, and this is the tool after I turned 63 of those small stainless parts, and I didn't have to change the wear offset on my digital at all, or regrind the tool. It held up perfectly fine, because when I ground the tool I first used a D125 diamond wheel, which is a general purpose medium roughness wheel, and then I went over it with a D40, which is a very fine diamond wheel. It's almost a lapping wheel, and such a good surface finish and an edge without any imperfections holds up very long and very well, even if used without proper cooling. I run this tool only with a little bit of cutting oil. So yeah, that's the way I changed the grind on this insert. So these are 63 of the bushings turned from one side, drilled and parted off. Next step will be to put them back in the lathe in a collet with a depth stop, face them to length, and put the 5.5mm bore in them. Then I clamped them the other way round in the collet chuck and I used the purpose ground tool to put on the 27-degree chamfer and face tank to length. And here you can see a picture of the tool. The front portion cuts the chamfer and the rear is relieved so I can take a facing cut with it. And that way with the purpose ground tools, this job really went very fast. Then the drawing called for a 8mm bore with a flat ground, and I did that with an end mill held in a boring bar holder that I could use like a boring bar. As it was a carbide end mill, it was very stiff, and I took one roughing pass and one finishing pass and got it right on size with a flat bottom. Perfectly fine. And here are the finished 61 bushings, ready to ship. Okay, I guess we're done for this episode. I will take part in another Richard King scraping class, this time in Germany, end of November, down at in Stuttgart, in a open workshop, like a paid hacker space. You go in there and you can buy time on machines or on mill or on just bench space and use their equipment. And that's where the scraping class, organized by BX, will take place. The space is called Hobbyhimmel, which is freely translated, it would be something like Hobbyist Heaven. They're very well equipped. They have a Deckel FP2 milling machine with accessories, a Colchester lathe, a large sliding table saw, slider table saw, all kinds of woodworking equipment, welding equipment, electronics lab, 3D printing, really everything that you may need to make stuff. That's where the course will happen. Richard asked me to help him out with translating this time, and I happily agreed. I will try to get some video and photo of the show. I will try to get some video and photos of the scraping class again, if I'm allowed to take photos in this space, which is always something you have to check if you do video or photo. Another thing, I was at the Emo 2017 trade show, which is world's largest trade show for machine tools, machinery, metrology, stuff like that. I can tell you, I was there for 2 days and I didn't see half of the stuff there at all. It's overwhelming. I don't care much for the machinery. Milling machines get faster, bigger, more precise every year. That's a given. Same for lathes, grinders, EDM and stuff like that. I care more for the tooling, setup tools, metrology, cutting tools, stuff like that. That's what I'm personally interested in most. And I saw a lot of neat things for milling machine setup, stuff like that. Unfortunately, I didn't get much photos of the show. I took about 15 photos or something like that, and I cannot really show much of the trade show itself. John Saunders, which I met at the show, which was a blast. I'm really happy to have him met finally. He's such a nice guy. There is a photo of us on Instagram that he took. We both, at least I look a bit wasted in that photo, but don't worry, that's how I look all the time. And John has a great video of the Emo trade show, about 1.5 hours of footage. Watch that if you're interested in the show. I unfortunately didn't take much at all. I think that's pretty much it. Thanks to all my new subscribers. I'm going steadily up to 30,000 subscribers, and this is crazy. Imagine having 30,000 people in my shop and looking over my shoulder. It would get quite crammed in here. I hope that most of the people are really interested in the stuff I show and not only accidentally clicked at the subscribe button, which I would appreciate too, but I would prefer to have people that are really interested. So, thank you all for watching and see you next time.